Welcome to a new e-learning paradigm, AplusMap.ai.
Hey there, econ students, and welcome to the Explainer. Today, we are diving deep into a concept that is absolutely critical for your AP exams. We're talking about the inverse relationship between marginal product and marginal cost.
So, have you ever really thought about this? Let's say you start a business. You hire your first couple of employees and things get way more efficient. But then, as you keep hiring, something weird happens. Your cost for each item actually starts to go up. Why? Why does that happen? Well, that is the exact puzzle we are going to solve today.
To figure that out, we have to get really comfortable with one specific word. And seriously, this might just be the single most important word in all of AP economics. And that word is marginal.
So what's it mean? In econ speak, marginal is just a fancy way of saying the next one. It's the change you get from adding just one more unit of something. It could be the extra cost, it could be the extra money you make, or in our case today, it's the extra stuff you produce. It's all about that one additional unit.
And listen, for all of you getting ready to crush those graphs on the exam, here's the secret. Marginal is just code for slope. That's it. So the marginal cost, it's the slope of the total cost curve. The marginal product, you guessed it, it's the slope of the total product curve. All right, enough with the theory. Let's make this stuff real. We're going to open up our very own cookie shop, and we're going to see these ideas play out in the real world. Honestly, it's the best way to see how it all fits together.
So every single time we think about hiring a new person for our shop, we've got to ask these two super simple questions. First, how many more cookies did this new hire actually help us make? That's our marginal product, or MP. And second, what did it cost us to make each of those extra cookies? That's our marginal cost, or MC.
Okay, before we jump into the numbers, let's do a super quick review of our cost family. You've got fixed costs, like the rent for our oven. Those don't change no matter how many cookies we bake. Then you have variable costs, like paying our workers. Those definitely change. Total cost is just adding those two together. And finally, the star of our show, marginal cost. That's the extra cost for baking just one more cookie.
And here we are. This is the heart of this entire explainer. There's this one simple but incredibly powerful formula that connects how productive our workers are with how much our cookies actually cost to make. This, my friends, is the golden link.
There it is. Marginal cost equals the wage rate, we'll call it W, divided by the marginal product. You need to write this down. I mean it. This is so important. MC equals wage divided by MP. And it just makes sense, right? Think about it. If your new hire is a total rock star and adds a ton of cookies, that means their marginal product is high. Well, then the cost you paid them gets spread out over all those cookies, making each one cheaper. But if they're not so productive and only add a few cookies, then the cost per cookie has to go up.
Okay, time to put it all together. Let's take our cookie shop, our cost ideas, and that golden formula and see what happens. It's time to run the numbers. So first things first, our assumptions. We're going to pay every worker we hire a wage of $60 a day. Our rent for the oven is a fixed cost, that's $120 a day, period, and our output, which is Q, is just the number of cookies we churn out. Now this is where it all clicks. Let's look at that first worker. They add 5 cookies, so their MP is 5. We use our formula. This $60 wage divided by those 5 cookies, that's a marginal cost of $12 per cookie. Now, watch what happens. We hire a second and third worker. Their marginal product actually goes up to 7 and then 8. Why? Because they're specializing. As their MP rises, look over at the MC column. It's falling from 12 down to 857, all the way to a low of 750. But hang on, look what happens after that third worker. The fourth worker, they only add 7 cookies. The fifth adds just 6. Their marginal product is falling. This is the law of diminishing returns in action. It's literally too many cooks in the kitchen. And as that MP falls, our marginal cost has no choice but to start rising again.
So let's zoom in on that sweet spot. The lowest possible cost for us to make one more cookie, our point of peak efficiency,
is $7.50. And when does that happen? It happens at the exact moment our marginal product hits its maximum of 8. Do you see it? That is the inverse relationship, right there in the numbers. Maximum productivity means minimum marginal cost. You know, that table of numbers we just looked at, that's the secret origin story for one of the most famous graphs in economics. Let's connect that data and see exactly why the marginal cost curve has that classic U-shape. So, in phase 1, when we're hiring our first few workers, they start to specialize. One person mixes the dough, another works the oven. Their efficiency, their marginal product, goes up. And as that happens, the marginal cost for each cookie goes down. That's what creates the downward sloping part of the MC curve. Then we get to phase 2. The kitchen's getting crowded. People are bumping elbows. Diminishing returns kick in, and productivity starts to fall. So as marginal product goes down, the marginal cost of making each extra cookie has to go up. And that's what creates the upward sloping part of the curve. And there you have it. You put those two phases together, and you get the classic graph shapes you've got to know. Marginal product rises and then falls, making a sort of hump shape. And because of that perfect inverse relationship, marginal cost falls and then rises, creating its famous U-shape. They're mirror images of each other. Okay, we've covered the theory, we've got the formula, we've seen the data. Now let's do a quick check to make sure this is all sinking in. All right, you're up. Your next hire has a marginal product of 6 cookies. Their wage is still $60. What's the marginal cost for each of those cookies? Just plug it into the formula. Yup, you got it. It's the $60 wage divided by the marginal product of 6. That gives us a marginal cost of $10 per cookie. It's as simple as that. And for the last challenge, I want you to think bigger than the math. Think about the relationship. If a worker's productivity, their MP, doubles, say from 4 to 8, what happens to the marginal cost of each cookie they produce? The answer to that question, well, that's the main idea of this whole explainer. Thanks for tuning in.
We hope you're excited for what's next. For more learning materials, please visit aplusmap.ai.